Hey there everybody! So we just finished up our lesson on solving one-step inequalities, and we've done that with addition and subtraction and with multiplication and division. Today, as you might guess, it's all about solving two-step inequalities. So I can solve two-step inequalities. I spelled that wrong. Let me try that again. Inequalities. There we go. Okay, so how do we solve inequalities? Quick review here. We solve inequalities just like we solve equations, except when we multiply or divide by a negative number. And in that case, we switch the direction of the inequality. So if it was greater than, it turns into a less than. All right. So here's what I want you to do. If you feel super confident about solving two-step equations, and if you remember the whole thing about switching the sign if you multiply or divide by a negative, then I want you to hit pause and try to solve these questions on your own, these math problems on your own, and then fast forward through the video and see if you got them right. Now, if you would like a little bit more support and you want a little bit more step-by-step guidance, then keep this video rolling and I'll walk you through it. Let's start with example 1a. Okie dokie. We have 65 is less than negative 6n minus 1. Okay, so what are we going to get rid of first? We want to keep the n over here. That means we have to get rid of the negative 6 and we have to get rid of the minus 1. Which one's going to go bye-bye first? Well, you want to get rid of the one that's not attached to the variable. So you see right now how the negative 6 is attached to the variable? It's right beside it because it's multiplying. You want to get rid of the one that's further out. You want to get rid of the one that's added or subtracted first. And we're going to get rid of it by performing inverse operation. Right now it's minus 1, so we're going to do plus 1. And of course, what you do to one side, you do to the other side as well to keep things even. 65 plus 1 is 66. I didn't multiply or divide by negative, so I'm just going to bring down my sign as is. And then that went to 0, so I'm just left with minus 6n. Okay, now I still need to get that in by itself, so I've got to get rid of this negative 6. Again, we're going to use the inverse operation. Right now, they're multiplying, so to get rid of it, I'm going to divide by the number that I want to get rid of. The number I want to get rid of is negative 6, so we're going to divide by that. And right now I'm thinking, oh, wait a second, we're dividing by a negative number. That means I've got to remember to flip my sign, so for me, I like to circle it just as a reminder, you know? Okay, so those will cancel out. 66 divided by negative 6 is going to be negative 11. Now I'm going to flip my sign. And then you're just left with n over here. Okay, now this is the solution. I'm seeing on some people's homework, a lot of people's homework, that you're not writing the solution out. So everybody just double check as you're doing your work today and make sure that you're writing the solution out like this and you're graphing it. We got to have both things. It's like you're writing the answer two different ways. Okay, so n, I'm going to read from the variable. Actually, no, I'm skipping a step here. Let's put 0 on the line and let's put negative 11 on the line. Negative 11 has to go to the left because it's a negative number. Okay, now I'm going to read from the variable. N, n is less than negative 11. So less than sign is going to get an open dot. And in other words, the answers are all less than negative 11, so the answers are going to be to the left. That's where the smaller answers live, is to the left. If it was bigger than, then it would go off to the right. Okay, and so that's number 1a. Let's go on to b. Okay, so this is a little bit different here. You have x minus 6 all over 9 is greater than or equal to negative 1. Now you can't mess with the x or the 6. You can't really do anything in there until you get rid of this denominator. So let's start by getting rid of the number in the denominator. So right now x minus 6 is being divided by 9. We're going to do the opposite, which is to multiply by 9. And then these two will just wonderfully cancel each other out. Let's make sure we do the same thing to both sides. So we're multiplying by 9 here and by 9 here. 9 is a positive number, so I don't need to circle my inequality. We're not going to change anything there. Now we're going to just bring stuff down. X minus 6 is greater than or equal to negative 9. Okay, we're almost there. Let's get rid of this minus 6. Right now we're subtracting 6. Let's do the opposite, which is add 6. And we got to do it to both sides. That's going to cancel, and you're left with x is greater than or equal to, looks like negative 3 there. So that's your solution, and now you're going to put negative 3 on your number line. You're going to decide if it's an open or closed dot. We're going to have a closed dot here because of that line that's underneath. The line, the or equal to part of the sign, means that you have to fill that dot in. And what does that indicate? That just tells us that the negative 3 is part of the solution. Okay, now we just need our arrow. X, or in other words, the answers are greater than negative 3. The answers are bigger than negative 3. So we want to highlight those bigger numbers, which are those ones that live off to the right. Okay, that's it for that one. Let's do C. Okay, in this case, we have another fraction. Let's just go ahead and read it first. 3 minus x over 2 is greater than or equal to negative 8. Okay, so you see how the 2 is kind of stuck to the x? Sort of like the negative 6 was stuck to the n here. So you don't want to get rid of that one first. You want to get rid of this number that's sitting over here by itself first. So it looks like that 3 is being either added or subtracted to the x over 2. So we want to get rid of it by doing the opposite of it. This right here is a positive 3, so we're going to subtract 3 to get rid of it. Okay? And when you do the 3 minus 3, then you're just going to get 0 and it's going to go away. Let's make sure we do the same thing to both sides. Now we're subtracting a negative 3. Do I need to circle my sign and to flip it? No, not in this case. You only flip it when you multiply or divide by a negative. Okay, let's bring everything down. Now we're going to have negative x over 2 is greater than or equal to, let's see, negative 8 minus 3 is going to give us negative 11. All right, so now when you have negative x over 2, you could think of it as a negative x, or you could think of it as a negative 2. I'm going to think of it as a negative 2 because it's going to help me solve the equation. So I'm going to scribble this out, and I'm going to put the negative right there in front of the 2. You don't have to scribble it out, just only if it helps you visualize what's going on. So now we clearly have x being divided by negative 2. How are we going to get rid of that? We're going to use the inverse operation. We're going to multiply by negative 2. And we're going to do that on both sides. Now hold on a second. We just multiplied by a negative number. So what can I not forget? Don't forget to flip the sign. Okay, let's keep simplifying. This and this are going to cancel out, leaving us just with the x, which is great. And then we're going to flip our sign. And then negative 11 times a negative 2, let's see, a negative times a negative equals a positive, so we're going to get positive 22 here. So our final solution here is x is less than or equal to 22. Let's put it on our number line. Let's go ahead and graph this. So here's my 22. I'm going to fill in my dot because I have that or equal to part of the sign. So I need to use a closed dot. And now let's see, x, or in other words, the answers to this problem are all less than 22. The range of answers are smaller than 22, so let's draw our arrow towards the smaller numbers, and then we're done. As you do your graphs, make sure you have clearly either an open or closed dot and an arrow that's clearly going to the right or to the left, okay? Awesome, thank you. Let's go on to D. Okay, negative 31 is less than 9 plus 4n. What are we going to get rid of first? As we're trying to get that n by itself, we need to get rid of the negative 9 and we need to get rid of the 4. Right now that 4 is stuck to the n, so let's not mess with it. Let's get rid of the negative 9 first. So adding 9 to both sides. Okay, so negative 31 plus 9, we have different signs, so we need to subtract. That's going to be negative 22. Okay, so negative 22 is less than, this goes to 0, and you're just left with 4n. Okay, and now we have 4 times n, so we're going to do the opposite of multiplying, which is divide. You're going to divide by the number that you're trying to get rid of, in this case, the 4. Negative 22 over 4. Okay, now let's just simplify. Those are going to go away. I don't need to circle my sign because we're just dividing by a 4 here. It's a positive number, so nothing's going to flip. Negative 22 over 4, I'm going to turn that into a decimal because I feel like that's easier to deal with, especially as we're graphing it. So negative 22 divided by 4 is going to give us what we're looking for here. And it looks like negative 5.5 is what we're looking for. So negative 5.5 is less than n. All right, let's get negative 5.5 on the graph. Here's our 0. I'll do negative 5 here, negative 6 here. So let's do, how about negative 5.5 right in between those two numbers. Okay, now open dot or closed dot? Open dot because there's no line underneath. So that shows us basically that negative 5.5 is not one of the answers. The answers come all the way up to that number, but it doesn't include that number. Okay, so I'm going to read this from the variable. So or in other words, the answers are greater than negative 5.5. So I'm going to draw my arrow off to the bigger numbers. You could say negative 5.5 is less than the answers. That works too. Just whatever makes more sense for you is what you should say. Let's go to this last example. We have another one. So is this set up more like this one, or is it more like this one? It's more like this one because you have that big fraction, like the big long fraction bar, and everything is over the denominator. And when you have that, you always have to get rid of that denominator first. Let's read the problem first. 3 is less than or equal to 3 minus x over negative 4. When you have a problem like this, you always want to get rid of that denominator first, just like I said. And what's happening in this? Right now, the 3 minus x as a whole, it's almost like they're in parentheses, right? That whole binomial there is being divided by negative 4. So let's get rid of that by multiplying by negative 4. So we're going to multiply by negative 4 on both sides. And, oh, wait, we multiplied by a negative. Let's go ahead and circle that sign so we don't forget to flip it. Okay, negative 4 times 3 is going to be negative 12. Now we're going to flip that sign so it's going to face the other way. And now this 4 and that 4 cancel each other out. They essentially equal 1, which just makes them go away. So we're left with just 3 minus x. Okay, we still need to get that x by itself, so let's get rid of the 3 next. Right now this is a positive 3 that's being added or subtracted to the x, so let's get rid of it by doing the opposite. We have a positive 3, the opposite is going to be a minus 3. Okay, negative 12 minus 3, let's see, same signs, add and keep. So we're going to add the numbers together and keep that negative sign. And do we need to flip this? No, all we did was subtract 3, so we don't need to flip. And now that goes away and we're just left with negative x. Okay guys, is this good enough? Is this x by itself? No, not yet. The x is not by itself until you get rid of the negative sign. So you could think of this two different ways. You could either multiply both sides by negative 1, or you can divide both sides by negative 1. Both are going to give us the same thing in the end. I'm just going to multiply by negative 1. And since I'm multiplying by a negative, I better remember to flip this guy. Okay, now let's do the math. Negative 1 times negative 15 equals positive 15. Now let's flip the sign. Negative x times negative 1 is going to equal positive x, just like we wanted. We wanted that x to be positive, now it's positive. So this one was a little bit crazy. Did you notice that we flipped the sign twice? So it started off as less than or equal to, and then it went to greater than or equal to, and then in the end it went back to less than or equal to. That can happen. You might even have problems later on where you flip it 3 times. It can happen, but just make sure you're keeping track of it, and every time you multiply or divide by a negative, just flip it, and then you will be on the right track. Okay, we're almost done with this. Let's put it on the graph. You've got 0 here. Let's put our 15 over here. We've got the or equal to, so let's draw a dot and let's fill it in. And now let's read it from the variable. So x, or in other words, the range of answers, are greater than 15. The answers are bigger than 15, so we got to draw towards the bigger numbers. You could read it the other way. You could say 15 is less than the answers. That makes sense too. Okay, so your assignment is 14 problems. If you work on it for a long time, like 30 minutes, and you've only done like 10 problems or 8 problems, that's totally fine. Just make sure you're doing a good job on the individual problems, thinking things through, remembering to include your graphs and to flip your signs, and you'll be in super good shape. Thanks so much for watching, and have a good one. I'll see you next time. Bye.